dear students, in the previous class we have studied how in a covalent compound we are seeing the ionic character due to the polarity, isn't it? In this class we will be studying how in an ionic compound the covalent character is seen. This is being explained with the help of Fajans rule. So let us start. So if the cationic size is less, and the anionic size is more, it means if the cation size is smaller than the anion size, it will have more covalent character. Now if the charge of the cation is more, like Na plus Al3 plus, charge of Al3 plus is more. So if the charge is more on the cation, it will show more covalent character. So if we are taking sodium and aluminium, what will happen? Which will show more covalent character? That is aluminium, because it is having Al3 plus, isn't it? And Na is having only 1 plus charge. Now if the cations now are of same size, and they are having same charge also, so here what will happen? We will be seeing if the elements are belonging to the transition metals typically, they will have more covalent character rather than those elements which are in sp blocks. So now we are going to study valence shell electron pair repulsion theory. In short we say Vesper theory. Now actually what does this theory do? It predicts the shape of the covalent compound. We are studying only from the starting itself. Kosel and Lewis and all are trying to just say about the shape. But some problem or the other arises by their theory. Here we are also seeing that yes, this can say or predict the shape of the covalent compound. This was first said by whom? Sedgwick and Powell. They said what? Repulsion interaction of the electron pairs in the valence shell atom. So what is this repulsion interaction of electron pairs? Actually when the electrons are present in the valence shell, they are negatively charged, and if they are negatively charged, naturally what will happen? There will be repulsion, isn't it? Because like charges, negative charges, and this is explaining that only repulsion interaction of electron pairs in the valence shell atoms. They will try to repel each other, isn't it? Getting? So it was redefined by Nyholm and Gillespie. Now the main postulates was given by whom? The Sedgwick and Powell. First we will be studying about their postulates. These postulates, first what was it? It said about what? Shape. And this shape was what? The number of valence shell electron pair present in the last. It means the electrons present in the valence shell. And it could say about the shape, because this valence shell electron pairs only what they do. They are found in the lone form or in the bonded form, and that is only determining the shape. Later we will be studying. Now the pair of electrons, the valence shell, repel on each other, in the electron cloud, and they are because they are negatively charged. Here, what happens? When the electrons are present in the valence shell, what happens? They will try to repel each other. They both are what? All the electrons are what? Negatively charged, and as the result, it will not be so close to each other. Because what happens? Like charges repel each other, and as the result they will repel each other, in the electron cloud. They will get arranged in such a manner, so that they can remain in a stable form. And what happens? This space of electrons, what happens? They occupy the space in the cloud where there is minimum repulsion. It means there is distance between the electrons. And if there is no distance, less distance, naturally it will remain unstable. As the result, what will happen? It will try to arrange the cloud so that there can be minimum repulsion and there should be maximum distance between them. Now next, the valence shell is supposed to be a sphere. What? Sphere. The valence shell. Now if there is a multiple bond, it is considered to be a single pair only. And yes, if there are two or 3 okay bonds more present, what will happen? We say that, they said, not we, they said that these are what? Single super pairs. Okay, so we're not saying double bond or triple bond. Okay, we're saying what? Single super pairs. Okay, 2 or 3. Now here this Vesper theory is applicable for what? Resonance also. Getting here, the structure represent any molecule. Okay, if it is in the resonance form, this Vesper theory is applicable, or this Vesper model is applicable for resonance also. So we were studying about the repulsion among the electrons in case of what? Valence shell electron pair repulsion theory. Okay, so now continuing that, we see what? That lone pair has got maximum repulsion. Okay, then comes what? Lone pair and bond pair, and then comes bond pair and bond pair. So by seeing this, Nihom and Gillespie, okay, what did they conclude? That yes, there is a difference between the electrons of lone pair and the bond pair. Okay, and this was explained. Okay, how? See, what happens? Central atom, okay, is present, and in this lone pairs are also there, bond pairs are also there. When the lone pairs are there, lone pairs of electrons will be what? With the central atom only. Okay, but what happens to the bond pair? It is just making a bond with another atom, isn't it? So what happens? These lone pairs are nearby to the central atom, but these bond pairs are a bit far off. Getting? And as the result, if these lone pairs are near to the central atom, it is with the central atom, what happens? These electrons are present over there, both are negatively charged. You can see these are negatively charged. So what will happen? Repulsion will take place, and this repulsion will be maximum then, because here when we are seeing bond pairs, it is attached to other atoms, so it will be far from the central atom. So here the repulsion will be less. So according to this, the geometrical shape can be given by the central atom in two forms. Whether the lone pair electrons are present or they are not present. If it is not present or if it is present, yes, it will affect the geometrical shape of that molecule or compound. So by the concept of given by this Nihom and Gillespie of the lone pair and lone pair bond pair repulsions, okay, geometry where that could be explained if lone pair is present or if lone pair is not present. So if lone pair electrons are not present, so which type of geometry it will be? Suppose in the valence shell only 2 electrons are present in the central atom. It is arranged, okay, you can see over here only 2 electrons are there attached to other atoms, okay, and as the result it gets the shape what? Linear, okay. It can be seen in case of beryllium chloride, mercury chloride, okay. So here there are number of examples given in table 4.6. Okay, in the page number of NCERT 114, you can go through that, and according to the concept you can just say about its geometry. Okay, again next, if in the geometry can be explained if what? The lone pairs are present. Okay, if lone pairs are present, their geometry will be different. Okay, so here I have taken an example of AB3E. Okay, it has been taken from the page number 115, table 4.7. Number of examples are given in NCERT. You can go through that also according to the concept. You can make it out. So one I am explaining it. Okay, so here in this you can see how many bond pairs are there? 3. So 3 bond pairs, lone pair only 1, isn't it? And as the result, which type of structure will come? Here lone pair electrons are with the central atom, only 1 pair, okay, and 3 bond pairs, okay. And as the result you will see that its geometry is tetrahedral, but its shape is trigonal pyramidal, okay. And this is an example of what? NH3 molecule. Okay, so this valence shell electron pair repulsion theory could able to predict the geometry of large number of molecules, and especially the p block. Okay, it was able to say all the shapes and about its geometry. Okay, then accurate, it was accurate even when the energy difference between the possible structure was very slow. Even though if the energy was very slow, small, not slow, okay, very small, okay, it could say about it, it's a what? Shape, okay, and it's a geometry. But by theoretical basis, okay, the effects of electron pair repulsion was not clear. It could say about the geometry, it could say about the shape, but its effects of electron pair repulsion, why it is happening, why this shape is only coming, why another shape is not coming, okay, they were not, this theory was not able to, I'll say, explain totally, completely, or it was not clear, okay. So this is all for today. Good day. Take care.